All right, concavity, that's going to be tied in with second derivative. So f of x, our function, is concave up if y prime is increasing on its interval. So y prime has to increase. F of x is concave down if y double prime is decreasing on its interval. So this needs to be double prime right here. So that's a whoopsie instead of prime. What does concave up mean? Concave up just simply means that like a mirror or something like that, we have this sort of a shape going on where we've got a curve in our graph and the top part is open. A concave down would be where the top part, is pointed down. I don't know. But concave up, this is up right here. This is down right here. So here's concave up and down. It's just the curvature of the graph, okay? So concave up happens when y prime increases. So when y prime is greater than 0. Concave down happens if y prime decreases, okay? And you have a point of inflection when y prime is equal to 0. Okay, you've got a point of inflection when y prime is greater than 0. You could also say that you're looking for y double prime to be greater than 0 and y double prime, not pi, y double prime to be less than 0. Okay, so pretty cool. And at this point where the derivative equals 0, that's our point of inflection. So let's check it out here. Determine whether the function is concave up or down, and we're going to look at x squared, okay? And we're going to look at the interval from 3 to 10, not including 3, not including 10. So the derivative, first derivative, is 2x. Second derivative is 2. So what does this tell us? Well, let's set the first derivative equal to 0. X equals 0. Okay, no problem. Second derivative is 2. So what does that tell us? Where is it concave up or down? Well, something's going on at 0, all right, because that is the place where our derivative is equal to 0 as far as finding a maximum or minimum. But we're not allowed to use 0 because it's outside of our interval. So then we go to our second derivative now because we're trying to determine concavity up or down. Okay, that's what we're really interested in. Well, if you look down here at 2, that's our second derivative, and 2 is positive. That's greater than 0. Okay, so 2 is greater than 0. And since that's true, from 3 to 10, we are concave up. Okay? Now, think about what you know about the graph of x squared. Think about what you know. Okay? It's going to be a shape like this. Let me put the actual graph in a different color. It's going to be a shape, something like this. All right? This is totally concave up the whole way. And we're not interested in the whole graph though, because what the question said was the question said, hey, we're going to start here at 3 and we're going to go over here to 10, and we're just interested in this part. Well, that little piece of the pie, that little piece right here from here to 10, that's what we're interested in. Well, that's a concave up shape, and we can tell that because our second derivative is greater than 0. Okay? Okay, now let's look at the second part here where y is equal to 3 plus sine x. Again, we're looking from 0 to 2 pi. So, if you think about what's going on with that graph, so our original graph is going to be, up at 3, and we're going to go up, we're going to come down, and we're going to go back. And so here's our 0 to 2 pi graph. And if you don't remember, use a graphing calculator to crank it out, but you're looking at pi being right here and 2 pi being right here. So pi over 2 and 3 pi over 2. And what we're going to do then is we're just going to try and figure out, obviously, this part right here, this is concave down. And obviously this part right here, this is concave up. Okay. So we need to find out at what point are we switching from concave down to concave up, and there is a specific point on that. So what do? We find derivative, and the derivative of 3 is 0. Derivative of sine x is cosine x. Okay, second derivative of the cosine is negative sine x. Okay, so what we want to do is we want to find where these are equal to 0. Okay, so where's the sine of x equal to 0? And the sine of x is equal to 0, and we're looking at right here at these from 0 to 2 pi. 0 is not included, okay? But the sine of x is equal to 0 at 0 and pi and 2 pi. Okay, but remember we can't include the 2 pi and the 0 part, but we do need to use them as our guide to determine what is going on. So we're gonna start here at 0. We're gonna go to 2 pi. Whoops, let's call this guy pi and 2 pi. And we're gonna make a sign chart because where we change from concave up to concave down is our point of inflection. And there is a change in that because the sine curve doesn't sit still at all. So we're going to take negative sine x and put him over here. And then we're just going to plug some numbers in. So if I go from 0 to pi, okay, if I go from 0 to pi, my sine curve is going to be negative, okay, because it's a negative in the front. So any value from there would take on that guy. And then when I go from pi around to 2 pi, the sine curve is going to be positive. Okay, so what does that mean? That means from 0 to pi, and you can pick any point in here. For example, you can pick pi over 2, and you can pick 3 pi over 2. That'll make this a true statement. All right, and when you check these 2 points, you're going to find that you get a negative number and a positive number. And check it out. It matches our graph. Look, we're concave down here. We're concave up right there. And where does it change? It changes at pi. So we're concave down, then we're concave up. And we can determine all of that from second derivative.